Okay, so we are going to calculate the energy change in this reaction. This reaction is called the Haber process. Okay, it's a very famous reaction, it's a very, very useful reaction for the production of ammonia. So it's really important in the making of things like fertilizer. Okay, it's a really, really important reaction happening all the time. All right, but we want to know what is the energy change in this reaction. And this is how we're going to do it. And this is how you should do it whenever you're doing any kind of calculation like this. To start with, we're going to split the page in two. Okay, and we're going to split it where the arrow is in the reaction. Okay, and we're going to calculate the energy of bonds broken. Because remember, in order to do this reaction, we need to break the bonds in the reactants and then make the bonds in the products. Okay, so the first thing we need to do is draw out all of the things that are involved. So I've got one molecule of N2. Now N2 looks like this. It's a triple bond. It means it's got 3 shared pairs of electrons. They are all covalent bonds. And I've got 3 molecules of H2. H2, H2, H2. And then I'm making 2 molecules of ammonia, which is NH3 and NH3. Okay, so it's really important that you look at the numbers in front here to know how many of each one there is. Okay, and you can see that those numbers make sense because here I've got 2 atoms of nitrogen, here I've got 2 atoms of nitrogen, here I've got 1, 2, 3, 4, 5, 6 atoms of hydrogen, and I've got 1, 2, 3, 4, 5, 6 atoms of hydrogen. So the equation is balanced. All right. Next, I'm going to write in my bond energies. So I look at my table. Nitrogen triple bond 9, 4, 5. Really strong bond. 9, 4, 5. Hydrogen 4, 3, 6. 4, 3, 6, 4, 3, 6. Those are all the same. And then I've got my NH. These are all NH bonds. So if I look, my NH is 391. So I've got 391, 391, 391, 391, 391, 391. So now I can work out my total energy of the bonds broken, which is going to be 945. 436, 436, 436. Add those up. And over here, well, I've got 1, 2, 3, 4, 5, 6. They're all the same. So I'm going to do 6 times 391. So if I do those two sums, what do I get? Well, I get over here 945 plus 436 plus 436 plus 436 is 2253. And over here, I've got 6 times 391, which is 2346. Okay. And the units for both of those is kilojoules per mole. Kilojoules per mole. Okay. So now we need to think about what do these numbers mean. So let's start off on our reactants. Okay. So, this number here, this is the energy transferred from the surroundings to the reaction. For what purpose? Why are we doing this? We're transferring it from the surroundings to the reaction to break the bonds in the reactants. Okay, and then this number over here is the energy, well, now it's the energy that's released when we make these bonds. So it's the energy transferred from the reaction to the surroundings when what happens? When the bonds in the products are formed. Okay, which you'll remember from, we talked about that in the last video. All right, so let's think a little bit more detail. So what's going to happen in the reaction? So if I'm transferring energy from the surroundings to the reaction, the energy in the reaction is going to increase by 2253. So this is plus 2253 kilojoules per mole in the reaction. And what happens to the energy in the reaction when we make these bonds? Well, energy is transferred from the reaction to the surroundings. So energy is leaving the reaction. So we can think about this as being minus 2346 kilojoules per mole. And if you wanted to, we drew a picture of this in the last video that looked like this. So we draw our usual reaction profile. Okay, so this is progress of the reaction. This is our energy. And we started with our reactants and we finished with our products. And we said that the first thing we do is we put energy in to break the bonds. So that is energy in to break the bonds. How much energy in this case? Well, we put in plus 2253 to break the bonds. And then, so now we're up here. We've broken all of the bonds. What are we going to do next? We're going to make some new bonds. All right. And when we make new bonds, energy is released. So the energy in the reaction goes down. And in this case, it goes down by minus 2346. Okay. So it's really important that you remember that this is bond breaking. Bond breaking. And this over here is bond making. Now, what was my original question? What was the thing right at the start, right at the back of the start of the lesson? Where was it? All the way back here. How do I calculate the overall energy change? How do I calculate this number? Well, we're now in a very good position in order to be able to do that, because the quantity that we want to calculate is this number here. This is the overall energy change. Okay, overall energy change. And you can see from this picture that that is a simple sum of 2253 minus 2346. And if I do that, I get 2253 minus 2346 minus 93 kilojoules per mole. Okay, which is great because the negative sign means it is exothermic, and you can see from my reaction profile that my products are lower in energy than my reactants, which is what you would want for an exothermic reaction. Okay, so that's the explanation for how to do it. All right, but I'm going to give you one tip, and that tip is that the overall energy change equals the energy of bonds broken minus the energy of bonds made. Okay, you don't need to worry about, so here I did a little bit of thinking about what the sign would be, whether it's exothermic and endothermic, which you need to understand, but if you're just calculating the energy change, you don't need to worry about that. You just do the energy of the bonds broken minus the energy of the bonds made. So I could have stopped all the way back up here and just done 2253 minus 2346. Okay, and it's always that. So it's always the number from the reactants where you break the bonds minus the number from the products where you make the bonds. This number minus this number. Okay. Right, so now you need to have a go at one, and that is going to be, we'll start with a nice straightforward one. So I want you to work out the energy change in this reaction. So it's 2H2O goes to 2H2 plus O2. All right, so have a go at working out the energy change in that reaction. So hopefully you've got something that looks like this, and then you're going to write in all of your bond energies, like so. And then once you've done that, you're going to add those all up to work out the total energy. So here you would do 4 times 464. And here you would do 436, 436, 498. And you would work those out as 1856 and 1370. And then we would do, it's the energy of the bonds broken minus the energy of the bonds made. So it is simply the energy change is 1856 minus 1370, which is 1856 minus 1370, 486. All right, and I'm going to put a plus sign in there just so it's clear. Plus 486 kilojoules per mole, which tells me what? Well, it tells me that that is an endothermic process. Okay, which means that if I want to get hydrogen from water to use as a fuel, or to get oxygen from water to use as a fuel, I need to put in a lot of energy. I need to put 486 kilojoules of energy per mole in, which is why we can't use hydrogen and oxygen from water as a fuel. Okay, so that one was nice and easy. Let's do a slightly more tricky one. So the next one I want you to do is this one. So we're going to do C2H4 plus 3O2 makes 2CO2 plus 2H2O. Now I'm going to be nice and I'm going to tell you, you should be able to work this out for yourself, but I'm going to tell you that this structure is this. Okay. However, I'm not going to tell you what the structure is for the rest of them because you should know what those are. So, off you go. Have a go at working out the energy change for that reaction. Okay. You should have listed out all of the structures of the reactants and the products, and then you would have added in all of the bond energies so that you've got something like this. And then you're going to add them all up. So I can see here that I've got 4 times 413. I've got 1 times 612. And I've got 3 times 498. So if I do each of those calculations, so if I do 4 times 413, I get 1652. 1 times 612 is 612. And 3 times 498 is 1494. If I add those three numbers up, I get 3758. And then I look at the products. So I've got over here 4 times 805 and 4 times 464. So if I do those, do 4 times 805, 3220, 4 times 464 is 1856. And I add those two up, I get 5076. And then the same as before, the energy change is just this number minus this number. 3758 minus 5076. So 3758 minus 5076. Minus 1318. Minus 1318 kilojoules per mole. Which means what? Well, because it's negative, it means it is an exothermic process. What does that mean in terms of energy transfer? It's an exothermic process. What does it mean in terms of energy transfer? It means energy is being released from the reaction into the surroundings. Okay, so energy released to the surroundings, or energy transferred. Energy transferred to surroundings. So would you expect the temperature to go up or down? We would expect the temperature to increase. That's what happens in an exothermic reaction. And that should not be a surprise. And the reason it shouldn't be a surprise is because this reaction is a combustion reaction. All right, this is ethene combusting with oxygen to give us carbon dioxide and water. So this is just burning of a fuel. All right, so whenever you do these calculations, you can always look at your number and think, does this number make sense for my reaction? In this case, it's a big exothermic number. So it does make sense because you would expect a lot of energy to be released in this kind of reaction. Okay, so you now need to do for homework the questions that I've set you in the task. All right, I need to just make sure you should know what these structures look like. Okay, I think we all know what H2Cl2 HCl look like. We all know H2O2 H2O, CH4 no problem, no problem, no problem, no problem. C3H8. Okay, so C3H8 looks like this. C3H8 looks like this. That's C3H8. And CH2CH2, that is this, same as this. So CH2CH2, that's the same as CH4, C2H4. CH3CH3 you should be able to work out, but I'll just so we're completely clear, it is, ooh, what have I written there? That's not it. CH3 should be this. And CH3CH2OH, well, we did that in the last video. If you remember, we had the structure of that back here. Okay, so you need to do those and submit them on the form that I've sent out. All right, and it's really important that this is it's a long process, and there's lots of opportunities to make mistakes, but it is quite straightforward. It's just lots, and all I've done is I've just looked numbers up in a table, and then I did some multiplication and some addition, and then finally a subtraction. So it seems like a long process, but it's not really. Okay, so if you can master this, it's easy marks. All right. Okay, good luck.